Welcome back, Chemistry 30. So we'll look at an example dealing with this. So we talked about when these are in acidic solutions. So we'll do two examples with that. Then we'll look at what happens in basic solutions. It's only a slight tweak, really. And then we'll do two examples with that. So we'll complete and balance this equation by using the method of half reactions. So again, we mentioned that oxygen and hydrogen likely aren't going to go oxidation reduction. So it's the other substances that we're worried about. So we know that something's going to happen to Cr and something's going to happen to Cl. So what I'm going to do is I'm going to split this page in half, work each half reaction separately, then bring it together at the end. So we know that Cr is undergoing a change, so let's write that down as one half reaction, because we know something's going to happen there, and we know something is going to happen with the Cl. Okay, and we're going to follow those steps that we looked at before. So we figure out the two half reactions, balance each one, balance the items that aren't H or O, then balance extra O's by adding water, balance H's to account for that water that we added, and then finally make sure the charges are balanced as well. So first of all, looking here, Cr, I have two Crs, I have one Cr. So guess what I have to add? Or I have to ensure that I have two Crs. Next on the list, I was supposed to balance oxygens. And yes, I have oxygens on the left, I have none on the right. So I am going to have to add water to increase the number of oxygens. So 7 O's. So to get 7 O's, I need to put a 7 in front of there. And of course, the next step, look at that, I've added 7 times 2. I've added 14 H's, so I have to add 14 H's. So as you can see, that is balanced. I have 14 H's on each side, 2 Crs on each side, and 7 O's on each side. Okay, so I've completed all of these steps here, balanced anything that's not H or O, balanced O's, balanced H's. Now I need to figure out the charges on each side and add electrons on the more positive side. So if I look here, I have some positive ones, and I have 14 of them. And over here, let's see, I have one of these ions, and that's a charge of 2 negative. So that's going to give me a total of 14 positives and 2 negatives, 12 positives. Over here I have some 3 positives, and I have 2 of them. And over here, water, of course, is neutral, 7 of them. So that's going to give me 0, 2 times 3, 6 positives. All right, so the charges don't balance. So remember, I'm allowed to add electrons. I add electrons to the more positive side. So I'm going to be trying to bring this positive 12 down to positive 6. And I can do that by adding 6 negatives in the form of 6 electrons. So how this would appear then, I would have 14 H pluses plus Cr2O7, 2 negative, plus 6 electrons to give me 2 Cr3 plus 7 H2O. There we go. So that half reaction is balanced. And then we can see that was the reduction. It got reduced because I had to add electrons there. All right. This next one. Oh, it's going to be easy. Look, there's no O's or H's to balance. All I have to worry about is putting a 2 in front of here to ensure that I have the right number of chlorides. Over here I have some, so I don't have to add water, I don't have to add H's, so I just have to worry about charges now. So I have 1 negative here, I have 2 of them. That gives me a total of 2 negatives. And of course that is 0, so that gives me 0. So the more positive side is this. And adding electrons, so I'm going to try to make this equal. I can do that by adding 2 electrons here. Because remember, you want to bring the more positive side down, because that's what adding electrons does. So to rewrite this, 2Cl negative becoming Cl2 plus 2 electrons. So we know that this is the oxidation part of the reaction because it released 2 electrons. All right. So I've done all of that. So the next step here, multiply each half reaction to make the number of electrons lost equals the number of electrons gained, then add them, cancel out, etc. So here we can see we have 6 electrons. Here we have 2 electrons. The lowest common multiple of 2 and 6, of course, is 6. So times 3, and by times 3, I need to times everything by 3, triple everything. So triple, triple, triple. 2 times 3 is 6 CLs. 1 times 3 is 3. And 6. So there we go, I have that. Now, add both reactions. So I'm going to take this reaction and write it out. Write everything out there. 6 electrons yields 2Cr3 plus 7H2O. And it helps to line up the arrows here so you can see what's on the left-hand side, what's on the right. Because if you start writing the 6Cl here, then this arrow's over here, then it may be difficult to see what's reactant, what's product. But if you line up the arrows, it makes it a heck of a lot easier. So cancel like items on either side. So 6 electrons on the left, 6 electrons on the right. So those were used to help figure out the balancing, but now we can get rid of them. Then we have 14 H pluses, Cr2O7 2 negative, plus 6 Cl minuses. And over here we have 2 Cr3 pluses, plus 3 Cl2s, plus 7 H2Os. And what we should find here is that everything works. So 2 CRs, 2 CRs. 6 CLs, 6 CLs. 14 H's, 14 H's. 7 O's, 7 O's. Okay, so the number and types of elements works out. What about charges? Here we have a 1 positive. Or sorry, we have 14 positives. Here we have 1, 2 negative. Here we have 6 times -1, which is 6 negatives. So that's going to give us 8, 9, 10, 11, 12, 13, 14. So that's going to give us 6 positives overall on the left-hand side. Over here, 2 times 3 is 6 positives. Neutral, neutral. Look at that. So the number and type equal, and also the charges equal. All right. So what I'll do is I'll stop the video there. So you try the next one. So there's another example here dealing with acid solutions. You try that one, and then we'll come back and see how you did.